So now we are solving a new question, maximum subarray sum. So in this question we need to find the subarray which has the maximum sum. So let's take an example. Uh, Array -2, -3, 4, -1, -2, 1, 5 and -3. So this is the given array and we need to find the subarray which has the maximum sum. So what is subarray? Subarray means contiguous part of the array. Contiguous part of the array. So what is this? -2 is one subarray, -2 -3 is another subarray, -2 -3 4 is another subarray, or 4 -1 -2 this is one subarray, or this is one subarray. But you can't take this -3 -1 1. This is not a valid subarray. So this is not a valid subarray. These all are array subarray. So this is the definition of subarray. Now we will solve this question. So the first method, we can try out all the subarrays. We can try out all the subarrays. Like first we will take -2, then we will take -2 -3, then we will take -2 -3 plus 4, -2 -3 plus 4 -1. So some will be -2, some will be -5, some will be -1, some will be okay. So we need to try out all the subarrays. Oh, -2. So we need to try out all the subarrays and we will check whichever has the maximum sum. We will return that sum. Right now the -1 is maximum, so we will return -1, but we need to do this for all the values in the given array. This is when we start from -2. Suppose when we start from -3, -3 plus 4, -3 plus 4 -1, we need to do this for the entire array. So let's write a pseudocode for this. We will do iteration from for I is equal to 0 to n, for I is equal to 0 to n, and we will take a variable sum is equal to 0, and before this we will take a max sum whose value will be the minimum, now inner loop which will run from j is equal to I to n. So first of all we have taken this value and we will make all the subarrays including this, like -2, then -2 -3 and so on. So from I, suppose when I is equal to 0, j is equal to 0, so we will take only one sum plus is equal to arr j. And so for first subarray -2, we have summed the values, that is -2 now stored in sum. Then we will iterate second time in this loop. The values will be -2 -3 and -5. So at the same time we need to take the maximum sum. So max sum is equal to max of what, sum comma max sum, which is greater we will be storing in the max sum part. So at the same time we are taking sum of the subarray, and if that sum of that subarray crosses the maximum sum, we will update the maximum. If it is less than the maximum, we will do nothing, we will come outside the loop. And this is the first approach. So in this we are taking all the subarrays like -2, sum of -2, -3, and we will at the same time we are summing up these subarray, and if any subarray has the sum greater than the previous subarray, if any subarray has the sum greater than the previous subarray, we will update the max sum. So this is the pseudocode, and let's discuss about the time complexity. So it has a time complexity, as we can see easily that we are iterating all the subarrays, exploring all the subarrays of this array. So by taking -2, -3, -4, then again -3, minus and all the values, so it will take big O of n square. So the time complexity will be big O of n square and the space complexity of big O of 1. Now discuss the second approach. So the previous method's time complexity was big O of n square. Now we need to decrease this time complexity somewhere less than n square, somewhere less than n square. So method 2. So method 2. For solving this question, there is a famous algorithm named Kadane's algorithm. So now we will be solving this question using Kadane's algorithm. So what was the array? -2, -3, +4, 1, -2, 1, 5, and -3. This is the array. We need to find the sub array which has the maximum sum. So instead of iterating for all the subarrays, we will iterate this loop only once and update the maximum based on the condition. So let's dry run for this question. uh, Maximum we are taking, or then uh, maximum and a variable name sum. So when starting from the array, so starting from the array, we will take this value -2, sum will be -2. So before doing this, there is a condition, there is a trick for solving this question. There is a trick. If whenever sum is less than 0, basically negative, so then we will do sum is equal to 0. Whenever sum becomes less than 0 or negative, we will reinitialize it with 0. So now uh, come again to the question. First value is -2, sum is -2, but based on this condition, sum is less than 0. So we will cut it and make it 0. Then we will go to the next value, it is -3. So sum will get updated -3, but based on this condition, it is less than 0. So we will update it by 0. So now we will go to this value, sum will become 4, and now we will update max sum. Now we will update max sum. Max sum become 4. Now we will go to this value, -1. So 4 minus 1, 3. It is greater than 0, so no problem. We can go to the next value, -3. 3 minus 2, 1. So it is again greater than 0, so no problem. The next value is 1, we will increase it by 2. The next value is 5, we will increase it by 5. So increase it by 5, it will become 7. So now max sum. So another subarray has a value 7. So we will increase this 7. Now next value minus 3, it will become 4. It is greater than 0, so no problem. So we get our maximum subarray sum, that is minus 7. So let's discuss about the pseudocode. So for this we need to initialize these two variables. Sum is equal to 0 and max sum we are taking it int min. So i is equal to 0 to n, we will update the sum value arr I, and at the same time we will update the max sum if the new sum comes up greater than the previous sum. So max of sum comma max sum. If the new subarray has the maximum sum greater than the previous sum, we will update the max sum. And oh sorry, I forgot to write this condition. Before writing this max sum part, we will add if sum is less than 0 negative, then we will do sum is equal to 0. I forgot to write this condition. And now it's done. So let's discuss about the time complexity of this part. So as we can see easily that the we are iterating our loop only once from I is equal to 0 to n. So the time complexity will be big O of n, and the space complexity will be big O of 1, because we are not using any extra space. So this is the time complexity and this is the space complexity. So this is the Kadane's algorithm, which tells the maximum subarray sum, tells the maximum subarray sum. And there is a one important point. This algorithm, there is a there are few test cases on which this algorithm may get fail, like if we have been given an array like -4, -3, -2, -1. So when all the values are negative, based on this trick or condition, whenever sum get less than 0, we will do sum is equal to 0. So in this array, our maximum will become always 0, because all the values are negative, so some of these values will be negative. So whenever sum is less than 0, we will be doing sum is equal to 0. So for this particular type of questions, we will be getting sum is equal to 0. So we will be getting sum is equal to 0. So for this type of question, this algorithm may get fail. There will be solution for this. We will be discussing that in the next video. Okay, thank you.